first of 2 videos I will be posting for a review unit, since we will not be able to cover these topics in class due to the truncated schedule to begin the year. So in this case, we're going to start off by looking at algebraic equation solving and basic math mistakes. We need to make sure we're very strong on our algebraic skills and our ability to perform basic mathematical operations in preparation for this course, okay? So there will be some things that are assumed, but other things that we'll go over, since they do tend to be mistakes that are quite common on the exam. So no announcements here, because again, this is a session that we're not doing in class. So we start off with exponentials, something you should all be familiar with. If we have a to the x times a to the y, the result is going to be a to the x plus y. As an example, a to the second times a to the third is equal to a to the fifth. Similarly, for quotients, we're going to have, if we have a to the x divided by a to the y, we're going to have a to the x minus y. And as a result, we're going to have, as an example, we're going to have a to the seventh divided by a to the third equals a to the fourth. Power rules, if we have a to the x raised to the power of y, the resulting expression is going to be a to the x times y. So as a result, if I have a to the seventh raised to the second power, aka the seventh squared, that's going to be equal to a to the 14th. Negative rules. This is going to be standard in this class, especially when we get to Unit 2, okay? Whenever you see 1 over a to the x, you should always rewrite it as a to the negative x. So 1 over a to the fourth will always be rewritten as a to the negative fourth. Lastly, with the zeroth rule, people tend to think a to the zeroth power is always equal to 0. It is always equal to 1, okay? So please note the following point properties. A to 0 equals 1, not 0. A to the first power equals a, not 1. Please take note of this if this is something that's tripped you up in the past. The square root of a number a is represented as a raised to the 1/2 power. So square root of a equals a to the 1/2 power. That's another standard that you should get used to, rewriting square roots of a expression like square root of x or square root of y as x to the 1/2 or y to the 1/2 power. So, an example, simplifying with exponent rules. Let's simplify the expression x cubed times y divided by square root of y x to 2/3. So what we're going to do here is we start off by rewriting square root of y as y to the 1/2, and then we can now line up our variables right here in this next step, something I like to do but not 100% mandatory. So we see we have x to the third divided by x to 2/3. So we're going to have as a result, x to the third minus 2/3, and then y to the first minus 1/2. So as a result, we're going to get x to the 7/3 and y to the 1/2 as our result. And if you want to rewrite y to the 1/2 as square root of y at the end, that's perfectly acceptable as well. Expanding multi-term expressions. If 2 multi-term expressions are multiplied together, the result can be expanded by using the box method. Each expression is the length of a box, with the terms of each expression occupying a space of the region, creating a grid. For each respective position in the grid, multiplying the corresponding terms that intersected that position, and then add together the resulting like terms. This is something that should be familiar from Algebra 2 and pre-calculus. So expand the term x squared minus 2 times square root of x minus y. So again, we rewrite our expression as a length of a square or rectangle, with each part of the expression occupied by a term of the expression. So right here we have square root of x minus y rewritten as x to 1/2 minus y. Right here we have x squared minus 2 written as x squared minus 2. So now we fill in the blanks of each grid. X squared times x to 1/2 gives you x to 5/2. X squared times minus y gives you minus x squared times y. Minus 2x to the 1/2, we get right here from multiplying minus 2 and x to 1/2. And lastly, minus 2 times y gives us plus 2. So as a result, when we add together all of these terms, we're going to get that this expression, when it's expanded, is x to 5/2 minus x squared times y minus 2x to 1/2 plus 2y. Let's look at a more complicated example. The technique and logic is still the same as follows, but let's look at an example where we have 3 terms in each expression. So in this case, y squared, y, and minus 3 are going to occupy these 3 spaces right here. 2y, y cubed, and minus 6 are going to occupy these 3 vertical spaces right here. So as a result of multiplying, we get 2y cubed in this box, 2y times y cubed, 2y minus y gives us 2y squared in this box, and 2y minus 3 gives us negative 6y in this box. Proceeding so on and so forth gives us the resulting terms in each individual box. Y to the fifth, y to the fourth, minus 3y cubed, minus 6y squared, minus 6y, and plus 18. So as a result, when we expand this, we're going to add 2y cubed, y to the fifth, minus 6y squared, plus 2y squared, plus y to the fourth, minus 6y. Okay, so I'm going down the columns like this. Minus 6y, minus 3y cubed, and plus 18. Okay? So as a result, we're going to add together our like terms. The 2y cubed adds with the negative 3y cubed, which gives us a negative y cubed. The y to the fifth is by itself, so we get just a y to the fifth. Y to the fourth is by itself, so we get just a y to the fourth. And then we get a negative 6y squared plus 2y squared, which gives us a negative 4y squared. And lastly, we get negative 6y plus negative 6y gives us negative 12y plus 18. So some things to watch out for. A thing you may have learned about in Algebra 2. So a nice cheat code for expressions of the form a plus b and a minus b that are multiplied together is that the end result will always be a squared minus b squared, known as a difference of squares. The idea being is we take a plus b times a minus b, we're going to get a squared plus ab minus b squared. The middle terms cancel out, leaving you with a squared minus b squared. Please be careful. This is a very common math mistake. People assume a plus b to the nth power is equal to a to the nth plus b to the nth power. This is not true, and you should never try to simplify this way. And yes, you have noticed my voice has gone much more stern, and that's because I always see people make this mistake, and there's nothing you can do to circumvent this. You cannot write it like this. All right? So for example, if you have a plus b squared, this is equivalent to a plus b times a plus b. It must be expanded as such. It is not equal to a squared plus b squared. Do not be lazy and do not ever try and take the shortcut because it will always give you the incorrect answer. And yes, again, my voice is very stern for this part because it is such a common math mistake seen. So example 4, we'll look at solving equations in terms of variables. For AP Physics students, this may look familiar. This was from our math review in AP Physics last year. So if we want to solve an equation such as this for y, okay, this looks big and confusing at first because we have all these variables present. But the idea is that we can treat each of these variables, x and z, as if they were numbers and thus perform operations on them like they were numbers. So if we want to solve for y in this case, the first thing we do is get rid of z in the denominator by multiplying both sides by z, giving us 4z, on both sides. The z right here should actually be absent. I'm not sure how it got here. All right. So let's say it's y squared times x minus 3 over z equals 4. Again, the z shouldn't be here. That's a typo. So we multiply both sides by z to begin with to get rid of this z denominator, which gives us y squared x minus 3 equals 4z. So now the next thing that we're going to do is we have to get rid of this minus 3. So we're going to add 3 to both sides to get y squared times x equals 4z plus 3. Thus, as a result, we're next going to divide both sides by x, and that gives us y squared equals 4z plus 3 divided by x. Lastly, if we take the square root of both sides, that's going to give us y equals plus or minus square root of 4z plus 3 divided by x. Remember that when you take square roots, you always have to have this plus or minus sign here. That is such a common mistake seen in math. That's worth bringing up. You cannot forget the plus or minus sign when you take square roots like this, when you take the square root of both sides of an equation. So now we move on to solving equations containing polynomials. So recall that to find the zeros of a polynomial or the roots of a polynomial, we set the polynomial equal to 0, we factor the polynomial, and we set each of the factors equal to 0 and solve the resulting equation. Move back right here. So this is the basic procedure we need for solving polynomials. So let's look at procedures for factoring, okay? So on the AP Calculus exam, they don't want you wasting too much time with the quadratic formula or anything like that. In fact, it's actually much more important to know how to factor than to use the quadratic formula. So as a result, we're not going to go over the quadratic formula here. Egad! Gasp! A gasp goes through the crowd. So what we're going to do is our steps that we're going to follow is we're going to factor the entire polynomial. We're going to factor out any common terms at first. So if we have 3x to the fourth minus 6x squared, there's a common term of 3x squared on both these terms that we can factor out. So this is equal to 3x squared times x squared minus 2x. For polynomials of the form ax squared plus bx plus c, we're going to break the polynomial up into the following form. Blank x plus blank times blank x plus blank. Again, you could use the quadratic formula here, But the idea is with the AP exam, there are going to be parts where you have to factor, and thus it's more important to go by this technique than it is to by the quadratic formula. So what we're going to do is we're going to determine the factors of A to place next to X and determine the factors of C. So if A is equal to 2, the factors of A would be either 2 times 1 or negative 1 times negative 2. Okay, so we have either 1 or 2 or negative 1 or negative 2 for the factors of A. And then we're going to determine the factors of C. So C, if C is 4, okay, we would have, let's say, 4 and 1 and 2 and 2, or negative 4 and negative 1, or negative 2 and negative 2. This process sounds complicated in theory right now, but in practice it's not actually that bad. And it's something that can be done easily mentally. So next what we're going to do is use the trial and error to determine which combination of factors, when expanded, yields B. Again, this sounds exceedingly complicated, but most of the polynomials they give you on the AP Calculus exam are simple enough and straightforward enough that this can be done, again, mentally in your head as opposed to spending 10 minutes trying to figure out what the factors are. Okay? So let's see what this looks like in practice. So if we factor a quadratic polynomial where a equals 1, okay, the shortcut that you can use is when a equals 1 right here, the shortcut that you can use is we have to think about what two terms, when we multiply them together, give us negative 48, and when we add them together, give us negative 2. So let's see what that looks like in practice. So we're going to have x squared minus 2x minus 48 equals x plus blank, x plus blank. So again, we have to think about here what two numbers in these blank spaces, when we multiply them together, give us negative 48, and when we add them together, give us negative 2. So the factors of negative 48 are 1, negative 48, negative 148, 2, negative 24, negative 2, and 24, and so on. Now, you don't have to repeat this whole process right here, because doing a little bit of mental math in your heads, we can quickly identify that if we have negative 8 and 6 for the blank spaces, we're going to get a product of negative 48 and a sum of negative 2. So you don't have to write down all the factors. That's not required. I'm not going to require you to do that. You just have to do a little bit of mental math of identifying these numbers. So as a result, we're going to get x minus 8 times x plus 6 are the factors of our polynomial. So next we set x minus 8 and x plus 6 equal to 0 to solve for our zeros. So we're going to have x minus 8 equals 0. Gives us x equals 8 from one of the roots or zeros of our polynomial. And x plus 6 equals 0 gives us x minus 6 for one of the roots or zeros of our polynomial. Thus, the zeros of our polynomial are x equals negative 6 and 8. Determine the zeros of 3x squared minus 11x divided by 4. So now we have to break this up into two different possibilities. We either had 3x plus something times x plus something, or negative 3x plus something, negative x plus something. Okay? So the factors of negative 4 now we write down are going to be negative 4, 1, 4, negative 1, or 2, negative 2. Okay? So again, this seems exceedingly complicated, but you can do most of this stuff, this part right here on paper, and then you can do the factors part in your head. So by brief trial and error, what we can end up getting is we can see that if we have plus 1 right here, so 3x plus 1, and minus 4 right here, so x minus 4, that is going to end up giving us the correct polynomial. So 3x times x is going to give us 3x squared. Minus 11x, or excuse me, plus 1 times negative 4 is going to give us negative 4. And now if we take negative 4 and multiply it by 3, that gives us negative 12. And then x times 1 gives us just x. So we're going to get negative 11x when we add the two common terms together from expansion. Again, it sounds trickier than it is, but you've done enough factoring at this point from Algebra 2, Algebra 1, and Pre-Calculus, maybe Algebra 1, maybe not, that you should be able to look at expressions like these and do a little bit of brief trial and error. Again, the polynomials you'll see on the AP Calculus exam aren't exceedingly complicated, so they're not going to give you something that takes you like 10 minutes to work out. So we get 3x squared minus 11x minus 4 equals 3x plus 1 times x minus 4. So as a result, we set 3x plus 1 equals 0, which gives us x equals negative 1/3. And we set x minus 4 equals 0, which gives us x equals 4. So as a result, the zeros of this polynomial is x equals negative 1/3 and 4. So now let's look at a polynomial that has a degree greater than 2, where we can't use the quadratic formula. And again, this is why I don't like using quadratic formula, is because it only works for a specific case where you have a quadratic polynomial. So determine the zeros of 3x cubed plus 12x squared plus 54x. So what we can do first here is, going through our steps, we can realize there's a common term of 3x on both of these terms here. So we can factor out 3x. Thus, as a result, we're going to have with 3x times x squared plus 9x plus 18 equals 0. So we focus on the x squared plus 9x plus 18 now. This is quadratic, so we can factor it as x plus blank times x plus blank. So we need two numbers. We multiply them together, give us 18, and when we add them together, give us 9. And we can quickly identify that 6 and 3 satisfies both of these conditions. So our factors are x plus 6 and x plus 3. So we're going to get 3x times x plus 6 times x plus 3 as our factors. Now we can break each of these up and set them equal to 0. 3x equals 0 yields x equals 0. X plus 6 equals 0 yields x minus 6. And x plus 3 equals 0 yields x equals negative 3. There should be equal there, I forgot that. So x equals negative 6, x equals negative 3, and x equals 0 are the factors, or excuse me, the zeros are a polynomial. When dealing with an equation that's not immediately in polynomial form, let's say we had 3x cubed plus 27x squared equals negative 54x. You can convert it easily to a polynomial form by taking all of your terms and adding them to one side, such that the other side is equal to 0. So if this was 3x cubed plus 27x squared equals negative 54x, we would add 54x over to the left-hand side in order to get this result right here, such that our right-hand side is equal to 0. And thus we can proceed to factor as usual. So factoring a difference of squares is another nice cheat code. So if you have a polynomial with the form a squared minus b squared, this is a difference of squares, and you can immediately factor it as a plus b times a minus b. A nice little cheat code you can use to save time with calculations. So now we look at solving rational equations. Rational equations, if you don't recall from Algebra 2 or pre-calculus, are equations with at least one fraction consisting of a numerator and denominator that are both polynomials. So to solve a rational equation, you're first going to add or combine any expressions that have common denominators. Next, we're going to cross-multiply both sides to eliminate the denominators. And then we're going to resolve the resulting equation using the techniques that we just covered with locating the zeros of polynomials. And 4, we're going to check that solutions do not cause division by 0. We actually don't have to do this in this case. For AP Calculus AB, you can be assured that the solutions will not cause division by 0. But this is something in Algebra 2 that you would have to usually check for. So rational equations, determine the solutions to the equation 3z equals 2 plus 1 over z, or 3 over z equals 2 plus 1 over z. So the first step that we're going to do is that we can combine 3z and 1 over z by subtracting 1 over z from both sides. So as a result, we get 2z equals 2. Next, we cross multiply. So in this case, that amounts to just multiplying both sides by z to get us 2 equals 2z. And then we can solve for z by isolating z, giving us z equals 1. Lastly, we check for division by 0. Well, if z equals 1, that's going to give us 3 over 1, and that's going to give us 1 over 1. So there's no problem with the solution here. Hence a simple rational equation problem. Now let's look at a little bit more complicated problem right here. Okay? So what we can do right here is there's no common denominators that we can combine right here. Okay? So what we can do now is we can cross multiply. We can multiply top and bottom by x squared minus 4 and x minus 6. So that's going to give us x plus 2 times x minus 6, and that's going to give us 3 times x squared minus 4. The x squared minus 4 goes over to 3 as a result of multiplying both sides, and the x minus 6 goes over here to the x plus 2 as a result of multiplying by both sides. So as a result, we're going to get x plus 6 times x minus 6 times minus 3 x squared minus 4 equals 0. So now we're going to expand this expression out right here, which gives us x squared minus 4x minus 12. And then we're going to get minus 3x squared plus 12, because we have minus 3 times negative 4 equals 0. So what we see is the minus 12 and plus 12 cancels out, and the x squared minus 3x squareds combine in order to give us 2x squared minus 2x squared minus, let's see here, actually I may have made a typo right here. Let's check and see. Aha! I in fact did make a typo right here. Ah, darn, blast. So, minus 4x... No, wait, I have this correct. I am just living inside my head too much. Okay? Let's see right here. So as a result, we're going to have x squared minus 3x squared, which gives us negative 2x squared. Okay, and then we're going to have a minus 4x right here. So there is a little typo. This should be a minus 4x, but the problem-solving process is still the same. Okay, so we're going to have negative 2x that we can factor out. If we just forget the 4x and assume this is a 2x from this point on, forget my error. I do not make errors. I'm a math god. We're going to factor out the negative 2x that's common on both sides to get negative 2, or both terms to give us negative 2 times x plus 1. So as a result, we're going to get x equals negative 1 and 0 as our factors when we separate these out. Next, we can check for division by 0. No, there is no division by 0 here, so both our solutions are good to go. Again, there's a little bit of a typo right here, but if we proceeded as usual, we would get the correct answer proceeding by the steps previously shown. So lastly, we look at systems of equations. Specifically, we look first at the method of elimination. This is a lot right here. Do not copy this down. Do not worry about this. So method of elimination. This method is used if the coefficient of a variable of one equation is a multiple of the coefficient of the same variable in the other equation. So put into more concrete terms, if we have 6x minus 5y equals 8 and negative 12x plus 2y equals 0, we can notice that 12x is a multiple of 6x, or minus 12x is a multiple of 6x. We multiply this equation by negative 2, and 6x becomes negative 12x. The main point is to manipulate and combine both equations, such as to eliminate a variable, say x, and only have an equation of one variable, say y. We can then solve for the remaining variable and plug the solution into either of the original equations to solve for the other variable. So let's look at what this looks like in practice with the example we just talked about. Determine the solutions x and y to the systems of equations 6x minus 5y equals 8 and negative 12x plus 2y equals 0. So what we notice again is that negative 12x is a multiple of 6x, so we're going to multiply both sides by 2 here, not negative 2 as you'll see as you'll see why in a second. So multiplying this top equation by 2 gives us 12x minus 10, y equals 16. So now when we combine these two equations, the 12x and negative 12x are going to cancel out, okay, which is going to leave us with negative 10y plus 2y, negative 8, equals 16. So we get negative 8y equals 16, which yields for us y equals negative 2. So now what we can do is go back and plug y equals negative 2 into one of our equations. Either one is perfectly fine to solve for x. So we focus on 12x minus 10y equals 16. So we get 12x minus minus 10 times negative 2 equals 16, which when we simplify gives us 12x equals 36, or x equals 3. And thus is the method of elimination that you should have covered in Algebra 2 and pre-calculus. So now we look at systems of equations with the method of substitution. This method can be used in any particular case. The central concept is to solve for one equation for one of the variables in terms of the other variable. We then substitute this solution into the remaining equation. So as a result, we will have one equation with one variable that we can solve. Once we have found the solution for one variable, we substitute the solution into one of the original equations to solve the remaining variable. Again, that sounds like a mouthful. I usually like to illustrate things in terms of words to give you kind of the main concept, and then we'll look at applying in terms of a problem. So let's look at x and y for the equation 3x minus y equals 7 and 2x plus 3y equals 1. Please note that you could use elimination here, as 3y is a multiple of negative y. We just multiply this top equation by 3. But we're going to use substitution here in order to illustrate the technique of substitution. So 3x minus y equals 7 and 2x plus 3y equals 1. So first thing I'm going to do is I'm going to choose one equation to solve for y. In this case, I'm going to choose the first equation. So we solve for y by adding 3x to both sides or subtracting 3x from both sides. So we get negative y equals 7 minus 3x, or y equals 3x minus 7 when we divide both sides by negative 1. That just causes a sign flip. So now we take y equals 3x minus 7, and we plug it into our second equation for y. So instead of 2x plus 3y equals 1, we're going to get 2x plus 3 times 3x minus 7 equals 1. As a result, we're going to get 2x plus 9x minus 21 equals 1, or 11x equals 22, or x equals 2. Lastly, we plug x back into our equation for y right here. So we got x equals 2. So now we're going to plug it into the equation for y to solve for y. So y equals 3x minus 7 gives us, when we plug in x equals 2, y equals 3 times 2 minus 7, or y equals negative 1. Thus solving our system of equations using the method of substitution. And this covers the algebraic techniques that you will need for this class.